everyone, welcome to my channel. So this lecture is going to be a continuation of the previous lecture, lecture number 4, where actually we have discussed Laplace's equation for the steady state temperature distribution of the plate of a given plate, which is sandwiched between two insulating layers. So this is continuation of that lecture. So what actually we are going to discuss in this lecture? In the last lecture, we solved the Laplace's equation for a set of boundary conditions. In this lecture, we will take another set of boundary conditions and we will solve that. Okay. So let us start. We'll start with the Laplace's equation again and we will go on solving that one step by step. Okay. So the Laplace's equation for the steady state temperature distribution temperature distribution of the given plate or of the given conditions, okay, of the given plate is what it is. So in the previous question, uh, actually the unknown function is given as t, but in this question the unknown function is given as u. So we will write accordingly. So it is given by del square u x y by del x square plus del square u x comma y by del y square equal to 0 for 0 lying between x and L, x lying between 0 and L and y lying between 0 and B. Okay, so this is the Laplace's equation, two-dimensional equation, because along Z there is no variation of the temperature. So this is the Laplace's equation. Let us take this as equation number 1. This is equation number 1. Then next what? Let us now use the method of separation of variable and uh, reduce this second order partial differential equation into ODEs. Okay, because the unknown function is a function of two independent variables x and y. So we can reduce this given Laplace's equation into two ordinate differential equations. Okay, so let us start. So by using the method of separation of variables, we can represent the given unknown function u x comma y as a product of two two independent functions of independent variables. Okay, that is u x comma y can be written as x x y y. This is equation number 2. Let us now differentiate this equation number 2 with respect to x and y twice to obtain the values of second order partial differentiation of this one and this one. Okay, so let us differentiate. Let us differentiate equation 2 partially with respect to x and y twice to get, then what you will get? We will get del u by del x is equal to, at the time of differentiating a function partially with respect to one variable, the functions of other variables are uh, actually taken as constants. So here in this case, because we are differentiating u with respect to x, so y will be taken as constant. So we will get dx by dx into y, and del square u by del x square is equal to d square x by dx square into y. Again, del u by del y can be written as dy by dy into x, and del square u by del y square can be written as d square y by dy square into x. Let us take these two equations as equation number 3. Okay, let us proceed now. So next thing is, let us substitute these values into equation number 1. This equation number 1. Okay, so what you will get? You will get d square x, in this case d square x, okay, this one d square x by dx square into y plus d square y by dy square into x equal to 0. Okay, so you're right. Let us substitute the values of del square u by del x square and del square u by del y square from equation 3 into equation 1 to get, what do we get? We will get d square x by dx square y plus d square y by dy square x equal to 0. In the next step, let us eliminate this y from the first term and this x from the second term in order to make the terms independent of other variables. So in order to do that, what you have to do? Divide the whole equation by xy. Okay, divide the whole equation by xy to get. Now when we will divide the whole equation by xy, this y will be cancelled with this y. Okay, and we will get 1 by x. Okay, what we will get? 1 by x d square x by dx square plus 1 by y d square y by dy square is equal to 0. Okay, so if you look into the equation now, each term of the equation are that means each term of the equation carries only the functions of a same variable. Okay, so what we have to do now? Now we have to move this y into other side. Okay, what we will get? 1 by x d square x by dx square is equal to minus 1 by y d square y by dy square is equal to lambda square. Say, now you can, questions are in the previous part of this lecture. You have told that we have to take minus lambda square, then why we are taking lambda square this time? So if you look into the boundary conditions, Okay, let us go to the boundary conditions. If you look into the boundary conditions here, okay, what we are getting in this boundary condition? See. So when y is equal to 0, okay, y is equal to 0, u is equal to 0. When y is equal to b, okay, u is equal to 0. That means that this actually tells us an important information that y cannot be a hyperbolic function. That means y double dash by y means double derivative of y by y. This can't be positive. Can't be can't be positive. Okay. So in our that means what we can say cheat code, we can say that we can't take y as a hyperbolic function. So we have to take lambda square for that reason, so that the negative sign will be prevailed with the constant term. Okay, clear for that. Let us now return to that mm, last step. Okay, so here we have minus 1 by y d square y by dy square. We have studied that this can't be positive. This can't be positive means if we'll take minus lambda square, then this minus will be cancelled, and uh, derivative of y by y will become what positive. So in order to make it negative, we have taken minus lambda square in this case. Now what we will get, this will give us a set of two ordinary differential equations. How? See here, 1 by x d square x by dx square is equal to lambda square, and 1 by y minus 1 by y d square y by dy square is equal to lambda square. Okay, that implies on solving this one we will get d square x by dx square minus of lambda square x is equal to 0, and in this case this will carry a minus sign, so we will get d square y by dy square plus lambda square y equal to 0. So let us take this one as equation number 4, 4 and 5. Okay, so this one is equation number 4 and this one is equation number 5. Now this equation number 4 and equation number 5, they represent two ordinary differential equations. Okay, they represent two ordinary differential equations. Now the solutions to these two ordinary differential equations can be obtained by assumed solution method. Okay, so now the solution to the above ordinary differential equations can be assumed as how? So this one, for this one negative sign is there, so we will get a hyperbolic function. So what you will get, x as a function of x is equal to, so let us take a1 cos h lambda x plus a2 sin h lambda x. Okay, this one is equation number 6, and y is equal to, so we will get here c1 cos lambda y plus c2 sin lambda y. This is equation number 7. Okay, now we got x and y. Okay, clear about that. So next thing is what we know that the principle uxy is equal to, so we have what we have, uxy is equal to x x y y. So we can write that means what uxy is a product of this and this. Okay, but before that, in order to simplify our task, what we have to do, let us find A1, A2, C1 and C2 and then replace. Okay. So to find them, we have to use the boundary conditions. Let us take the first and second condition of the second boundary condition. What it is? Now by applying the boundary condition, what it is? That u x0 is equal to 0, we get. What do you get? When u y is equal to 0, x is equal to x, u x0 is equal to 0. That implies what? X of x and y of 0 is equal to 0. Now x of x cannot be 0. X function of x cannot be 0. So y, because if x as a function of x will be 0, then whole u will be 0. Okay, u will be 0. So this will actually give us a trivial equation. So in order to get a non-trivial equation, we have to equate y0 is equal to 0. That implies y0 is equal to 0. Now use equation number 7 here. In equation number 7, if y will be replaced with 0, we will get c1 cos 0 plus c2 sin 0. But we know that sin 0 is equal to 0. So this will become 0. Now cos 0 is equal to 1. So we will get only c1. So that implies c1 is equal to 0 using equation number 7. Okay. Using equation number 7, we got c1 equal to 0. Now, when c1 is equal to 0, let us replace this value, substitute this value c1 in same equation number 7. What you will get then? Y is equal to c2 sin lambda y. Okay. So, by substituting the value of c1 in equation 7, we get, what do we get? Y is equal to c1 0. So first term will be 0. Second term we will get c2 sin lambda y. Okay. This is equation number 8. Now apply the second condition of the second boundary condition, that is u xb is equal to 0. U xb equal to 0. What does it mean? That implies xx and y at b equal to 0. Okay, yb equal to 0. So as already we discussed, xx can't be 0. That implies yb equal to 0. Now look at equation number 8. Y is equal to c2 lambda y. Yb is equal to c2 sin lambda b equal to 0. Okay. So what we have used here? We used equation number 8. Okay. Next thing is what? C2 sin lambda b equal to 0. That implies, see, C2 can't be 0. Okay. So sin lambda b should be 0. Okay. So sin lambda b should be 0, as C2 cannot be 0. C2 0 means we will get a trivial equation. So in order to get a non-trivial equation, we have to make sin lambda b equal to 0. That implies lambda b is equal to n pi, or n pi for n is equal to 1, 2, 3 dot dot dot, or lambda is equal to n pi by b for n is equal to 1, 2, 3 dot dot dot. We can write this in more generalized form as, or lambda n is equal to n pi by B for n is equal to 1, 2, 3, dot, dot, dot. So we got lambda n is equal to n pi by B. Let us keep lambda n, value of lambda n here. Okay. Now return to the original equation. Okay. What the original equation is? So we have u x comma y is equal to x x y y, that is equal to x x means we have a1 cos h lambda x, okay, lambda x, and y means sorry, plus a2 sin h lambda x whole into y means here we have c2 sin lambda y. Okay, we have this one. So because we have obtained a general solution here, okay, so in generalized form, how can we write? That implies we can write un x comma y as, okay, x n x y n y, that is equal to xn means here we will get a 1n cos h lambda n x plus a 2n sin h lambda n x whole into c2n sin lambda n y. We got this one. Now let us use the second, okay, for this one, and for what? For n is equal to, 1 2 3 dot dot dot. So we can write this n is equal to 1 2 3 dot dot dot, and that means in the form of a summation here. So summation of what you can write, n is equal to 1 to infinite a 1 n, and this c2n also will be multiplied here. Okay, c2n cos h lambda n x plus a2n c2n sin h lambda n x whole into sin of lambda n y is equal to nothing. Okay, this much. Now no need to write n is equal to 1 2 3 because we have already mentioned that one in the form of a summation. Okay, next you can see here two constants a1 and c21, other means they are in product form. Here also they are in product form, so we can take this one as an, and this one is bn, and we can rewrite the equation as a summation of n is equal to 1 to infinite an cos h lambda n x plus bn sin h lambda n x whole into sin lambda n y, where an is equal to a1n c2n and bn is equal to sin, sorry, bn is equal to c2n a2n. Okay, so we got this one. Next thing is what? Let us use the first boundary condition. Okay, what does the first boundary condition say? When x is 0, okay, what is the first boundary condition? Let us refer that. Okay, first boundary condition, clear? First boundary condition, when x is equal to 0, y is equal to y, u is equal to u0 y by b. So let us write that one. Okay, now applying the first condition, now applying the first boundary condition, what you will get? Now u0 y is equal to u0 y by b. Okay, that means when x is equal to 0, u0y is equal to u0b. Let us use this value, this function, this value here in this equation. Okay. So what you will get here? That implies summation of n is equal to 1 to infinite. Now see here, when x is equal to 0, cos h 0 is 1, sin h 0 is 0. So we will get an sin lambda n y. So we will get an sin lambda n y is equal to u0y by b for, okay, this one we got. Okay, so this is one equation. Okay, let us name this as an equation. This is equation 8. This value of lambda n is equation number 9, and let us take this one as equation number 10. Okay, equation number 10, and this one as equation number 11. Okay, now this is in one such form where actually we can obtain the value of an by using Fourier's half series. Okay, Fourier's half series formula. Okay, so what it is now, by using Fourier's half range formula, we can write. We can write. So what we can write here? See, n is equal to. So see here, this is in terms of y. In terms of y means the limit of y is 0 to b. 0 to b. So we can write n is equal to 2 by b, 2 by b integration of 0 to b. Okay, then what is the fx here? U0 fy, in this case it is fy, u0y by b. So u0y by b whole into sin lambda n y, as it is sin lambda n y dy. Okay, clear? This will give us the value of an. Okay, let us solve this one. This is equal to, so what we will get here? See, below we have already one b and another b here, so we will get 2b squares. Okay, and u0, keep y inside and u0 by b outside. Okay, so what you will get here? u0 by b square to u0 by b square. Okay, and here we will get 0 to b, 0 to b y sin lambda n y dy. Okay, okay, so let us integrate this one. Okay, is equal to, so 2 u0 by b square, keep it as it is. This one we can integrate it by parts. Then y integration of sin lambda n y dy minus of integration of dy by dy integration of sin lambda n y dy whole into dy, bracket closed. Okay, and the limit is 0 to b. So let us solve this one. 2u0 by b square, and this will give us minus cos lambda n y by lambda n. So we will get minus y cos lambda n y by lambda n. Now minus, and here you will get minus cos lambda n y by lambda n, and here 1. So 1 by lambda n minus 1 by lambda n should be brought to the front, and we will get plus 1 by lambda n integration of cos lambda n y dy 0 to b. Okay, so let us proceed. What we will get? 2u0 by b square here, and here we will get minus. Now lambda and y means what? Okay, already we know that lambda and y is equal to from equation number 10. Okay, equation number 9. Equation number 9, if we look into this one, lambda and y. Okay, lambda and y means here b. Lambda and b is equal to n pi. Okay, so let us wait first, replace the value of y by uh, putting the limits, then we will put the value. Okay, let us keep it as it is. So minus y cos lambda n y by lambda n plus 1 by lambda n, and here we will get this one is integration. Okay, now this one, what you will get here? 1 by lambda 1 is sine lambda n y. Okay, so we'll get 1 by lambda n square into sine lambda n y, and the limit is 0 to b. Now if we'll put the value b here, okay, what you will get? B square. Now put b here, we will get minus b cos lambda n b by lambda n, minus b cos lambda n b by lambda n, plus sin lambda n b 1 by lambda n square sin lambda n b. Okay, now when we will put 0, then all the terms will become 0, because 0 into anything is 0 here, and sin 0 is 0. So we will write this much. Okay, now from equation number 9, lambda and b is equal to n pi. Now sin n pi is equal to 0. This is 0. Okay, sin n pi is equal to 0. 0 means this term will be neglected. Here cos lambda n b means it is n pi, and lambda n is equal to n pi by b. So b will come here. It will become b square, and down we will get n pi. So what we will get here? 2u0 by b square whole into minus b square. Okay, cos n pi by n pi. Lambda n is n pi by b. So what actually we did here? Lambda n b is equal to n pi, and lambda n is equal to n pi by b. These two values we have used here. So ultimately what we got here? 2u0 by b square is equal to this much. Okay, now b square will cancel, minus will come forward, and we will get 2u0 minus 2u0 cos n pi by n pi. This is the value of an. Okay, what we are getting here? An. So in an organized way, we can write an is equal to minus 2u0 cos n pi by n pi. Okay, this is equation number 12. Okay, we got an in this way. Okay, the next question number 12, I think. Yeah, right, equation number 12. Next, so from this equation, okay, we have used actually here one boundary condition, second, that means the first boundary condition, first condition. We have another condition also, second boundary, second condition of the first boundary condition. Okay, now applying the second condition of the first boundary condition. Okay, now applying the second condition of the first boundary condition, we get what do we get? Okay, what do you get here? See, what is the second condition? First of all, we know that is del u ly Ly by del x is equal to minus s. Del by del x of what? Uly. Okay, first let us take xy at x is equal to L. Okay, so what you will write? That is an cos lambda n x plus bn sin lambda n x, okay, whole into sin lambda n y bracket close at x is equal to L is equal to minus s. Now, while partially differentiating a function with respect to one variable, the functions of other variable will be taken as constant. So this is sin lambda 1, sin lambda and y is a constant. So what this will give us? This will give us an lambda n minus sin cos hx. Sorry, hyperbolic function here. H. So what you will get here? An lambda n sin h lambda n x, bn lambda n cos h lambda n x. So what you will get here? See here, an lambda n sin h lambda n x plus bn lambda n cos h lambda n x whole into sin lambda n y at x is equal to L is equal to minus s. Okay, summation. Okay, we left the summation n is equal to 1 to infinite. We can write here summation n is equal to 1 to infinite. That implies take the lambda 1 out. Okay, this lambda n out. So what you will get here? Summation of n is equal to 1 to infinite lambda n, then an sin h lambda n x sin h lambda n x plus bn cos h lambda n x into sin lambda n y. Okay, lambda n y at x is equal to L is equal to minus s. Let us now replace x by L. What you will get? Summation of n is equal to 1 to infinite lambda n, then an sin lambda n x will become sin h lambda n L plus bn cos h lambda n L into sin lambda n y equal to minus s. Now let us take this uh, whole term. Okay, this is lambda n. This whole term is uh, another constant, say gn. Okay, so let us take this one as gn. Okay, clear for that. So this lambda n will remain as it is. Okay, this side. So let us take this whole term as a gn. Okay, okay, so this one take gn. Okay, clear. So that implies what you will get? Summation of n is equal to 1 to infinite gn sin lambda n y is equal to minus s. Okay, minus s. So now this is that means this comes into one such form where actually we can apply the Fourier aspirant series to get the value of gn. Okay, so let us apply. Okay, now using Fourier's half-range series, okay, we get, what do we get? We will get, so see here, for this actually we are using uh, what you can say, that means the values y. Okay, y means it is 0 to b. So what you will get here? 0 to that means 0 less than y less than b. So within that limit we have to integrate this one. Now gn is equal to integration 2 by b integration of 0 to b minus s sin lambda n y dy. Okay, so this is equal to what? This will give us minus 2s minus 2s by b integration from 0 to b sin lambda n y dy. This will give me minus 2s by b, then sin lambda and y, integration of sin lambda and y, minus cos lambda and y. So minus cos lambda and y by lambda and limit 0 to b. Okay, so what you will get here? Minus 2s by b into cos lambda and y. Then we replace this one by b. What we will get? Minus cos lambda n b by lambda n. Then when you will get 0, then it will become minus cos 0 means 1 by lambda n. Okay, minus 1 by lambda n. Okay, so minus plus this one, minus cos 0 means minus 1, so this will be plus this much. Okay, clear about that? We are getting this one. Now we will get minus 2s by b into, so see here, we are getting 1 by lambda n into 1 minus cos lambda n b. Now cos lambda n b means what? N pi. Lambda n b means n pi. Okay, so we'll get this one as minus 2s by b, and lambda n means n pi by b, so b by n pi into 1 minus cos lambda n b. Okay, so this is what okay, we can get here. Okay, okay, we used the value here, lambda n is equal to n pi by b. Lambda n is equal to n pi by b. Okay, so that implies what? Lambda n b means n pi. Let us replace this lambda n b is equal to n pi here, and what we'll get? We will get minus 2s by n pi into 1 minus cos n pi, or in simplification form we can write this minus, if will be multiplied here, we will get 2s by n pi into cos n pi minus 1. Okay, so let us write this one. Okay, what is this gn we got? Okay, so that implies gn is equal to, we got 2s by n pi into cos n pi minus 1. Okay, this is equation number 13. Okay, now gn is equal to this much, but what is gn actually? Gn is what? But gn is equal to, that implies lambda n into an. We have taken gn. Okay, here, see here, gn is equal to lambda n, an cos, an sin h lambda n l plus bn cos h lambda n l. Okay, is equal to gn, an sin h lambda n l plus bn cos h lambda n l. Okay, this is equal to 2s by n pi into cos n pi minus 1. Okay, or we can write here, this is gn. Okay, the value of gn is this one. but an is known to us. Okay, lambda n is known to us, so we can find the value of bn here. Okay, so let us find the value of bn. So an sin h lambda n l plus bn cos h lambda n l is equal to 2s by n pi whole into cos n pi minus 1. That implies cos n pi minus 1 divided by lambda n. Now, bn cos h lambda n l is equal to what we will get 2s by n pi into lambda n into cos n pi minus 1 minus of an sin h lambda n l. That implies bn is equal to, so what you will get here, the 2s by n pi into lambda n, okay, whole into cos n pi minus 1, okay, cos n pi minus 1 minus of an sin h, an sin h lambda n l divided by cos h lambda n l. Okay, now let us use the values. Okay, lambda n, so what you will get, that is 2s by n pi, lambda n is equal to n pi by b, so n pi square at the top it will come b. Okay, lambda n is equal to n pi by b into cos n pi minus 1. Okay, minus an is equal to what, the value we got, an is equal to we have obtained minus 2u0 cos n pi by n pi. So minus minus it will become plus 2u0 cos n pi by n pi into sin h lambda n. Lambda n means n pi by b, n pi l by b divided by cos lambda n l. Lambda n l means n pi l by b. Okay, so in this we got the value of bn here. Okay, that is 2s b by n pi square cos n pi minus 1 plus 2u0 cos n pi by n pi into sin h n pi l by b. Okay, clear? So bn value is this one. Now we got bn, we got an, we got lambda n. Okay, clear? So what we can write here then? We can write, therefore the final solution is this is equation number 14. Okay, solution is u1 x comma y is equal to, okay, so what is the final solution here? Summation of n is equal to 1 to infinite, then an cos h lambda n x plus bn sin h lambda n y whole into sin lambda n x, this one lambda n x lambda n y, where an is equal to minus 2u0 cos n pi by n pi, bn is equal to, so what you got, 2sb by n pi square into cos n pi minus 1 plus 2u0 cos n pi by n pi into sin h n pi l by b whole divided by cos n pi l by b, cos h, this is cos h. Okay, cos h n pi L by B. Okay, clear about that. So this is Bn and lambda n is equal to what? And lambda n is equal to n pi by B. So this is the required expression, required solution to the given problem. Okay, so thank you for having patience to uh, see the solution, or that means learn the solution. Okay, like, share and subscribe to our channel. Thank you.